Welcome to Structural Engineering Online. In this video lecture, we will learn how to calculate support reactions of an overhanging beam. Please subscribe to our channel if you have not yet subscribed. In this question, we will learn how to calculate the support reactions of a double overhanging beam. Now, in this beam which is given below, we have two supports. One is pin support at A and there is a roller support at B. But if you see that on the left hand side of A there is some overhanging portion which is not supported. This is known as overhang. And similarly on the right hand side of B there is a portion of 2 meter which is not supported and that is carrying a load of 2 kilonewton per meter. And between the two supports there is a load of 4 kilonewton per meter. So this is the loading given on this beam which has overhangs on both sides. That's why it is known as double overhanging beam. If you want to see the example of single overhang, you can see our previous lecture which is available on YouTube. So first of all, we will define how many reactions are possible, because in this case there is no horizontal force, so there will be no question of horizontal reaction. We will see only vertical reactions in this case, and there will be one vertical reaction at A, one vertical reaction at B. So we will have two reactions here. We can show these reactions here, one reaction VA and one vertical reaction VB. So VA and VB are the two vertical reactions in this case. And to calculate the support reactions, we have to apply our equations of static equilibrium. And then, so first of all, this is sigma Fy is equal to 0. Sigma Fx is not required because there is no horizontal loading. So from here, when we say sigma Fy equal to 0, we will look for all the forces in y direction. So forces in y direction are the two reactions which are acting upward. So upward forces we are taking as positive and downward forces are taken as negative. Similarly, the moments which are anti-clockwise moments are taken as positive and clockwise moments are taken as negative. These are the sign conventions which we are adopting. So in this case now VA is upward, so plus VA, VB is also upward, plus VB, right? Then the loads which are acting on the beam, all of them are acting in the downward direction. This UDL is also acting downward. These are downward forces with the intensity of 4 kilonewton per meter for 3 meter and 2 kilonewton per meter for 2 meter length. Now we say here minus 2 because downward load to this load, okay. Then 4 kilonewton per meter over a length of 3, so minus 4 into 3. Then this uniform load on the right hand side of B, so it is 2 kilonewton per meter, so again minus 2 into 2 because 2 meter length. So this whole thing should be equal to 0 for equilibrium. So from here we can say that we get the value of VA plus VB equal to, and these values we can take here, 2 plus 12 plus 4 equal to 18. So VA plus VB is 18. Now we'll apply the third equation of static equilibrium, that sigma m about any point of this beam should be equal to 0. Now we can take moment about any point of this beam. For simplicity, we normally take the moment about any of the support so that one of that reaction will be eliminated. So we take moment about support A, sigma m A equal to 0. And when we take moment about A, we get the moment of this 2 kilonewton force. And if you look at the rotation of this 2 kilonewton force, it will try to rotate our beam about A and this is your point A. Look at the rotation like this, anti-clockwise positive. Okay, so plus 2 into 2. So this is the moment of this 2 kilonewton force. Now we have another load of 4 kilonewton per meter. It is over a length of 3 meter. So 4 kilonewton per meter, and we have this point A here, and this is your load which is acting downwards. So it will try to rotate in the clockwise direction. Clockwise moments we are taking as negative. So minus 4 into 3 into how much distance? Look at the center of this UDL. The center of this UDL is at a distance of 1.5. So we multiply by 1.5. Now we take the moment of this VB. Now VB will try to rotate the beam in this way. This is my point A, and this is VB. So the possible rotation is like this, which is anti-clockwise direction. So anti-clockwise we take as positive. So we get VB into the distance, which is 5. So from point B up to a 5. Now we have this UDL, which is 2 kilonewton per meter, and if we look at this UDL, this will also try to rotate the beam like this. This is point A, and then there is UDL, right? So in the case of UDL, the rotation will be clockwise, so we'll put it with minus sign. So minus 2 into 2 into the distance from its center up to point A. Here is its center. So from B it is 1. Therefore from A the distance will be this much. That means 3 plus 2 plus 1. That is 6. And this whole thing equal to 0. Now from here we get this value of VB easily. So we can write here that 5 VB, and then we have here 2 into 2, 4 will go on this side, so we'll write here minus 4. Then 4 into 3 into 1.5 will be how much? 18 on this side, so plus 18, and then 4 into 6, 24, which will be plus 24. Okay, so we have minus 4 plus 18 plus 24, and here we have 5 VB. Therefore VB is this total value divided by 5, and that total value is 38. So VB is 38.5 kilo Newton. Then we substitute the value of this VB in our equation here, which is VA plus VB equal to 18. Okay, so we substitute here in that equation. We have VA, then the value of VB is 38 upon 5, and this is equal to 18. Therefore VA is equal to 18 minus 38 upon 5, which will be 90 minus 38 upon 5, and that should be 52 upon 5 kilo Newton. So this way now we have seen that we are able to calculate support reactions of this double overhanging beam. I hope you like this video lecture, and if it has helped you in learning how to calculate the support reactions, please like it and share it with your friends so that they can also get the benefit of this video lecture. and you are also requested to subscribe to our channel so that in future when we upload new video lectures, you will also be notified. Thank you very much.